So this is the phenomenon that tells us about what the change in frequencies of the sound source and the listener, the person who hears the sound from the source. Then this is how you must write it when they ask you to define it. So you say Doppler effect, it is the change in frequency. The change in frequency or pitch of sound detected by a listener because the sound source. So it's very important for you to know how to define it. And the listener. This thing makes me to feel like I'm slow in reading this. Let me just keep quiet. I'll just read it and explain it after. Yes, so this is how you define Doppler effect. This is the phenomenon. All right. So it says the change in frequency or pitch of the sound detected by a listener because the sound source and the listener have different velocities relative to the medium of sound propagation. Let's just actually break it into parts, or to break it into simple explanations. So we talk about change in what? In frequency or pitch. Remember, pitch is how high or low a sound is, or frequency, right? Of sound detected or heard by the listener, the person who hears the sound from the sound source. Because the sound source is where the sound is coming from, and the listener, they have what? They have different velocities. I hope it makes sense. So, and the listener have different velocities relative to the medium of sound propagation, meaning that the velocities of the sound source and the listener, it will be different, or the velocities will be different. So this is how you defining it. I hope it makes sense. So mathematically, it has this formula: V plus or minus VL over V plus or minus Vs multiplied by Fs. So this is the formula for Doppler effect. So whenever they ask you to actually calculate whatever, this is the formula that you use. FL is the frequency of the listener. The person who heard the frequency from the sound source. So that detected frequency or that drawn frequency by the listener is known as frequency of the listener, measured in hertz. Then Fs is the frequency that is emitted by the sound source. So we call it frequency of the sound source, or frequency of the source. It's measured in hertz. Then we have, I hope it makes sense, we have VL, velocity of the listener. As we said that the listener and the sound source, they have different velocities, so they cannot have same velocities. I hope it makes sense. So velocity of the listener, then Fs, it is the velocity of the source, the velocity that the sound source is using as it is traveling or as it is stationary. I hope it makes sense. So the listener can be stationary or the listener can be moving. I hope it makes sense. When they tell you that the listener is stationary or the sound source is stationary, it means that the velocity is zero. I hope that makes sense. So that's very, very important, good people. Make sure that you understand this. If you didn't understand it, make sure that you actually understand the definition of Doppler effect. This will actually make sense to you only when you understand it, you interpret what that English says. Okay, so let's try to remove everything here. Okay, before that we have V. This is the speed of sound. This is the speed of sound. They can actually give you 340 meters per second or 343, somewhere there. But so they usually give you these guys. It can be speed of sound in air or speed of sound inside the water. But let's just call it speed of sound. So before you can calculate whatever, this is the formula that you use. FL equals V plus or minus VL, V plus or minus VS, or times V times Fs. So this is very, very important. Before you can say that the stationary listener, he is or she is approached by what? By the sound source or whatever. So before you can calculate, you actually make sure that you write this formula first. So FL is V plus VL, then V minus VS times Fs. We use this formula only when the listener is actually approaching the sound source or the sound source is approaching what? The listener. That's very, very important. Then we use FL equal to V minus VL over V plus VS. I forgot VS there. Then we use this formula only we talk about only when we're talking about what? About away. I hope it makes sense. But before you can choose the formulas, you start by writing that formula. FL equals V plus or minus VL over V plus or minus VS. Then if FL is greater than Fs, it means that we are talking about towards, meaning for us to say that it is towards, FL must be greater than Fs. For us to say that it is away, FL must be less than Fs. I hope that makes sense. If the frequency of the listener is greater than the frequency of the sound source, it means that it is towards. If the frequency of the listener is less than the frequency of the source, it means that away. I hope it makes sense. But before you can choose the formula, if it's towards or away, you write it as it is written there. V plus or minus VL, V plus or minus Vs times Fs. I hope that makes sense. It's very, very important, guys. You do not actually write, even if you saw that the car is going towards or approaching the listener, or the listener is approaching the car. Even if you can see that it is towards, you don't just write that formula as FL equals V plus VL, V minus Vs times Fs. You start by writing the combined formula as FL V equal to V plus or minus VL over V plus or minus Vs times Fs. Then after that, that's when you can actually conclude that, oh, this is the formula that I'm going to use. Since it is towards, I'm going to use the first one. Since it is away, I'm going to use this one. But for you to say that this is away, it means that the frequency of the listener, the frequency heard by the person, it must be less than the frequency that is emitted by the sound source, or where the siren is coming from. Then if it is towards, the frequency of the listener must be greater than the frequency of the source. I hope that makes sense, guys. Okay, let's just try to erase everything here, then we try to continue. Okay. Now let's talk about the distance and the relationship it has with frequency. Let's say this is person A. This is the listener or person A. Is standing there. Then let me draw my Mercedes Benz. This is my Mercedes Benz car, and this is the siren. Yeah, so it is emitting what? The frequency or the sound. Then this is the stationary listener. he is stationary, is not moving, meaning his velocity is 0 because he's not moving. He is stationary. Then this Mercedes car is actually approaching that stationary listener. So it is going towards the listener, right? Meaning FL must be greater than FS. Then this is the distance. Now, as the car approaches the listener, what you notice about the distance is that it decreases. This here is what is our distance. I hope it makes sense. So when the car approaches the listener, the distance reduces, or the distance decreases. Therefore, that results in a higher frequency. If the distance increases, it results to a lower frequency. So let's say this is the car and this is the listener. Then this is the distance between the listener and the car. But when the car actually approaches the listener, it means that frequency of the listener is less. I mean, when the car is going away, the frequency of the listener is less, then the distance is actually long. I'm not sure if I must use long or what, but I think you understand what I'm saying. Now, if the listener and the car, this is the distance, maybe the car approached the listener, it means that FL will actually increase while the distance decreases. Then if the car is moving away from the listener, it means that FL will decrease and the distance will increase. I hope that makes sense. I hope it makes sense, guys. So if FL decreases, it means that D increases. If FL increases, it means that the distance decreases. I hope it makes sense. When FL increases, then the distance decreases. It means that that's what it is towards. Then if FL decreases and the distance increases, that's away. I hope it makes sense. Okay. Then there are uses of the Doppler effect that you must know when they talk about the Doppler flow meter in humans. So let me try to write it down here because it's very important. They examine you guys using those questions. So it's very important for you to know those questions. But before that, please actually like the video and subscribe as we are continuing. I hope we are together so far. Now, the uses of Doppler effect. Okay, let's just use uses of Doppler flow meter. Doppler flow meter in humans. They can say states the 2 uses, or write down 2 uses of Doppler flow meter in humans. I'm just going to write 2 here. You can use your textbooks to write down the use of Doppler effects in traffic congestion. So the first use of a Doppler flow meter in humans is to determine whether the arteries, I'm not going to explain this, maybe you know this from biology or life sciences, to determine whether arteries are narrowed or attenuated. Then the second one is to determine the heartbeat of a fetus. You know this from life sciences. So these are 2 uses of Doppler flow meter in humans. You write these 2 to determine whether arteries are narrowed or attenuated. Number 2, to determine the heartbeat of a fetus. They use what? The Doppler flow meter. Or they can say write down a use of Doppler effect in a medical field. You must know
the uses of the Doppler flow meter in medical field. Then I think the second thing that you must know is to do whatever that's written on your screen as you are watching this video. Subscribe as we are continuing. If you do not subscribe, I won't continue. I'm kidding, but please guys, do subscribe and like the video. We'd actually appreciate that. It helps us to grow and to help a lot of people. All right, let's just continue then as you have